Hey guys! In this second part of the video series, I'll be upgrading the previous framework into a state machine. And to showcase that, I'll be adding a dodge roll mechanic. Now you may be thinking, what is a state machine? A state machine is a programming pattern that lets an object switch between a set of states. A state has its own behavior, and each state can transition between one another. Before I start creating my state machine, first thing that I have to do is to clean up the messy code that I started with. This includes proper naming of the variables and the nodes, and general fixes overall. After that, we can finally create the state machine class. This class handles the transition between the states and the processing of them. Before we get on ahead on creating the state machine class, let's create a boilerplate base for our state class. Our state class will include functions such as entering the state, exiting the state, processing the state, and handling the animation. We also need to create a signal to allow the state to transition from one another. After that, we can continue coding the state machine itself. The first thing that the state machine needs to do is to get the state themselves. After that, the state machine should have the ability to switch between the states. Of course, you also have to code the functionality for the state machine to process the state and the animation. With that, we're finally done with the state machine and the state. Let's start creating the state themselves. Let's start with the idle and the walking state. The idle state is pretty simple. When entering the state, it only plays the animation. And when the button is pressed, then it will transition to the moving state. Moving state or the walk state is also pretty simple. It just detects the move vector that we created last time and move accordingly. Of course, entering the walk state also plays the walking animation. After the idle and the walking animation, we can finally start adding the attack. In the previous code, we use a lot of variables just to make the attack work. But using the state machine, we can handle the logic of it separately without messing with the other. Just like the idle state and the walking state, when we enter the attack state, it starts the animation. The big difference here is that we are using the animation end function. When the animation end, it immediately tells the state machine to switch to idle. Let's try it out. And oh, you're getting stuck. Let's start the most fun part of any coding project, the debugging. After minutes of bashing my head on the keyboard, scattering print statement all over instead of using breakpoints, I finally managed to fix the attack state. And so, after everything, we can now finally start coding the actual feature that I really wanted to make, the dodge. Unfortunately, the asset pack I found doesn't have any dodge animation, so I had to improvise and use this hurt animation instead. It doesn't look good at all, but hey, we take what we can get. Coding the dodge is pretty similar to the attack state. It starts the animation, waits for it to finish, then switch to idle. We also have to create a new key binding for the dodge. We can now start modifying the idle and the walk state so they can transition to the dodge when the button is pressed. After those, time to debug the dodge. As you can see, we have our first problem. The dodge is too slow. Let's fix that. We can do that by adding a speed multiplier to the velocity change. Because the dodge is fixed, I just hard-coded a value. The speed is okay-ish for now, but another problem is that we are stuck on the dodge state. The animation end function is not firing correctly. After minutes of stubborn print statements to track the problem, it still doesn't work. So I took a deep breath and have some coffee. Sipping coffee, thinking about my life, seeing my motivation drain away, all the rejection, all the failures. When will this end? This constant cycle of rejections and failure, and oh my god, I forgot to turn off the loop mode. After a perfectly valid crash out, the dodge kinda works now. It's not stop anymore. The next thing to fix is the direction of the dodge. We need to find a way to track the direction the player is moving to. My first idea is to use the flip horizontal property, then I realized that's dumb. because that means the player can only dodge left or right. Not exactly useful. So after thinking and thinking, I just decided to save the last move vector value to a variable. We can then use that value when processing the dodge state. After all that, the crash out, the debugging, here's the glorious result. A working dodge or dash. It honestly looks like a dash to me, but whatever, I'm not going to rename the whole thing, but I am going to change that animation. Looks so off to me. I'm gonna be honest to y'all, I can't draw, I can do pixel art, so I'm taking the lazy way and just make the sprite rotate on screen, a dodge roll, basically. We can do that by using a tween. And with that, we are finally done. A serviceable dodge roll. Implementing a state machine is a ton of hard work, lots of bugs and rewriting, but honestly, all worth it. Doing a dodge roll on the previous framework would be a genuine nightmare. Spaghetti code of if statements and Boolean variables. This is better, I think. Anyway, we are finally done and we are moving into hitboxes and the actual enemy. Thanks for watching and see you next time.